can start.
Alright, welcome to this tutorial. We're going to be modeling the Kaplan turbine. In the previous one we did the Pelton, so we shall now dive into the Kaplan turbine. So from SolidWorks here, I have a new part created and we shall go through the same things. I have a reference image and then you'll be able to bring it to the part environment, get a plane, select sketch, and then go to tools and sketch tools, and finally sketch picture. So for this one, I'll pick my reference image and then put it to the center. Just take note of these dimensions. So I brought in this reference image to cater for the design of the nose cone, because it's this adjustable blade that water hits, and then based on this nose cone the turbine will spin the shaft and then the generator will be able to generate electricity. So from there I can name this one as the nose, pressing F2, nose cone. So select that plane, can save this as a Kaplan nose cone, or just Kaplan turbine. Yeah. We're going to draw the entire assembly as one part. Then the generator, rotor and stator will be up on top. So from there, go back to right plane. Want to generate this profile. So bring in a center line. Make sure it is horizontal based on this relation. And then I'm going to pick a spline and use it to generate that shape. So the beauty with the spline is you can adjust the curvature with ease. Okay, then we close off the top. Use trim. You can get a dimension to help us, say 75 mm. Okay. Now we can decide to make this a solid. We're going to features and use the revolve boss. So our axis of revolution is this line, and then that's when you have the cone. Yeah. Make sure you save this. Bring back the reference image. Go to the front of you. Our nose cone. Then let's deal with the shaft and then the propeller. Select that first. Go to sketch. It has brought for us the front of view. Okay. Then select offset. You already highlighted this. And then we go reverse. Let's try 5, 7. Okay. That will work. Extrude by 5. Select again that part. Go to sketch. Now we need the shaft diameter. Shall use 7 mm. Extrude, let's say by 135 mm. Okay, 135 mm. extrusion, diameter 7. Beauty with it, you can rename this. So this is our shaft, turbine shaft. Okay. Then now let's sketch the propeller. Alright, so this is the right plane, this top, and that's front plane. So we shall create another plane. Okay, there. Then we sketch on it. Still using spline. Alright. Alright, and that will work. Go back to the front plane, select sketch, and this sketch we offset. Let's convert. Remove the relation and see. Okay, need an offset. Alright, that offset, just need this to be variable. Alright, let's go back to the side view. Front plane still, features, we create another plane in the middle, that's 35. Go and sketch on it. Our geometry, because the geometry of the blade needs to be in a way that it's curved, right? That's what I'm trying to do. Because if you go to a reference geometry and you look at the blade is variable, right? From that angle. Okay. So you can then go to surfaces and you select boundary surface. Select the three important parts. First two, the direction. Now let's try formula. Now it's this one and that one, taking us to the third. Not the face, but the sketch. Yes. And then we do a thicken. Alright. Before even thicken, based on the front plane, okay, based on that plane, plane 1, add an extension, let's see by there. Then we sketch on it, and then that reference will convert. First need to convert, we do right, remove this, make it smaller. Okay, let's see. gray spline from here and okay. Connect this, suppressing, and back that. Surfaces, boundary surface, this edge, and then that. Alright. We do an adjustment again. This goes a bit high. And then now that's when you can do the thicken. Alright. And there, after you specifying the geometry of the blades, you can then now do a pattern. How many blades? 5, 6, depending on the design, your intention. So it's under circular pattern. You select the direction, and then here we're going to use bodies. Let's first remove the selection. Make sure, okay, let's see the bodies, solid bodies. Okay, so the bodies are, let's pick the reference. The bodies, we have the thicken 2 and 4. Yeah, we're dealing with this. The propeller blades are the adjustable blades, and we're doing equal spacing 360. Need 6. So now we have the shaft, the nose cone, the adjustable blades. And then now we shall do the generator. The geometry of these blades can be improved upon based on what you want. So you create a new part, and you create the generator rotor and stator. We add the diameter the other side at 7 mm. So that's it. And now we need to put an engulfing pin. This one can be for construction. Then we put this at 30 mm. Alright. 4. So we have this one as our generator. So we design the arrow. Okay, let's just offset. Offset by 1. Okay, that will do. You bisect it by into 2 parts. Leave it at an angle. So go to trim entities and remove the unnecessary parts. do a mirror. Make sure this is horizontal. Okay. Mirror entities, pick the two lines, mirror about there. So we have our arrow, we trim that center line. We could have made it construction. And alright, we don't need this one, we can trim or delete. Go back to extruded. And selected contours. Not a thin feature. Alright, let's examine this sketch. Alright, this should be coincident. Create closed environment. Let's try to extrude. Alright. So we need, let's say, 0.4. That's our arrow. And so save that. So let's do the same the other side. Nice. Put in a groove. So 7.3. Cut. Alright. Save. We create a new assembly. Bring in our Kaplan turbine. Then we bring in the generator. Let's adjust the diameter. Put 79. Alright. So I'm going to do mates. So first select the two parts. First one selected. Press Ctrl. Select the second part. Release Ctrl. And then you put concentric. And we flip. So you go to the mate and flip that arrangement. And finally, coincident. First part, press Ctrl. Second part, release, coincident. And we save the assembly. Save the Kaplan. So those are the mates, but we need to animate. Okay. Let's add in a gamete. This one, and then that one. Okay. Realize that they won't really work well because it needs to be fixed. One needs to be fixed onto something. Okay. If I fix this generator, will be kind of fixed. So we need a floating arrangement for this to actually be able to rotate. You get? So if I remove this gamete and I fix this rotates, but the idea is as the turbine rotates, this shaft should also be rotating. So you need to make both of them rotate due to the action of the other. Okay, let's see. This needs to rotate and that needs to rotate. So now, if you look at this geometry, you have the turbine, but then there's a coupling. Okay, so that's the one you're going to work upon. Impart. We skate the rotor shaft. Say 8. It's for the generator. It's the generator. Shaft. And then go back to the coupling and insert the generator shaft. Okay, let's remove this coincident relationship. Bring in the coincident mate. And then fix them. Also fix this. Okay. So we have that rotating. So now let's try the gear mates and the mechanical this and that. So you can see that operating. And now make some adjustments. Putting some color there. Make this bigger. Okay. And reduce. Okay. Back to the coupling. Can rename these two beds and we give them an appearance. Thick and 2 and then 2 and 4. And the remaining parts. Okay. Then we go to the fillets. Alright. Go back to the coupling. Save this. let's see it from this view. You can see the turbine is rotating the generator based on the input of water, and from this you can see water inflow, the adjustable gates, and then the blades. Even this show that up there of the shaft of the generator. Okay. Yeah, so that's it.